So recall that our main topic in this section is control flow. So control flow basically is the way to alternate the path of execution inside of your program, like in this loop where we loop certain number of times, re-executing these statements here and eventually getting out. So based on the logic of our program, based on the needs of our values, formulas, rules, and so forth, sometimes user input, we make decision to repeat something, repeat multiple parts, conditionally call functions, not to call functions, and all of this is generally falling into the category of controlling the flow of the program execution. So that's the main topic of discussion today. Of course, in order to approach our talk about conditions, we started with logical and relational operators, and of course we also talked a little bit about arithmetics. Like for instance, we introduced increment and decrement statements that allow us to make these types of updates to our variables. So one more part that I'd like to cover in this video is the switch statement. So as before, I'll just move this sample code down here, and what I'd like to try is that we'll try a little, perhaps like a pizza menu, right? So we would like to print this menu, and we can print something like 1 cheese, 2 can say mushroom, and number 3 barbecue, something like this, right? So we can implement this menu and ask the user what they want, and so let's get started with this. What we could do, we can create an integer pizza type, okay, pizza type, and ask the user to give us, by the way, I should scroll up to show you that I'm still using this IO stream. That's why character output and character input devices are still available. All right, so character input, we input this pizza type. So I'm expecting the user to type a number and provide us with the pizza type or the menu selection. Next thing that we could do is we could say if this pizza type equals, say, 1, okay, we can try something like give some output and say print enjoy. Okay, very good, and we can print new line at the end. Otherwise, if pizza type, I'll just copy and paste it from here, is number 2, we print something else. Bon appetit, if I spell this correctly. Okay, so to spell it correctly here. And then we can say else, right? Then we'll take everything else would be a barbecue, I guess. Or actually, you know, we could do different things. We could add another condition. So let's just say delicious. Okay, something like that. So we're trying to test the logic of this program, and perhaps before we get started with asking for pizza type, we can just print this menu to the user. So I can just print every part here. and we'll just do it as quickly as possible. We're just trying to demonstrate some choices that we have here. So just very quickly put this together to display this menu, really fix the syntax as quickly as possible. So these are strings that we print, and we also should give them a prompt, I guess. Your choice. Okay, very good. So this should be reasonable to begin with. So we can test this, and we can try running this. Build and run this. Right, so we have this menu, and then let's say number 3, barbecue. So delicious. So this seems to be working. What's advisable oftentimes when it gets to the territory of these magic constants 1, 2, 3 and so forth, it's really highly advisable to use maybe some constants. The simplest way to create them is to have this anonymous enumeration, and we can say pizza type right here and say cheese. Okay, say this is cheese, and this is, we have like 3 of them, and we'll just use unique constants for these, and barbecue like this. So in enumerated version of constants like this, compiler will assign numbers 0, 1 and 2 and treat these identifiers as constant integers. But look, my correspondence to our menu choices is 1, 2, 3. So I'll just assign 1 and say, let me start with ordinal number 1. And then this will be 2 and this will be 3. Okay, so this is my choice. So I just want to show you that perhaps using named constants in place of those 1, 2, 3, 4, 5 or some other types of numbers is a much better choice. Okay, so just an advice that even in this little coding example, I already begin to feel pressure for, to create constants and make the code much more readable. So I think pizza type equals 1 or pizza type equals this specific, clearly visible thing is a much better choice. Okay, so anyway, in cases when we have to rely on very specific set of encoded values like 1, 2, 3, which I use enumeration to give them names 1, 2, and 3. In these cases, although these if-else statements are very, very common in programming, there is an alternative choice which could make the code a little bit more readable, arguably. So let me show you an example. So I'll just preserve this entire demo because it's working and this was a good start for us. But now I'd like to replace this if-else struct that I have with a switch statement. So step by step how it works. First you say switch, and you use the parentheses. But here this is not a condition. What you need to provide, you need to provide your integral type, such as 1, 2, 3, 4, 5, to say let's evaluate it just once. And here I will replace it with the case like this, and with the case like this. Case like this. I actually should have used this mush pizza, and this will be used for the default. Okay, So everything else is delicious. In fact, this we can keep. And switch statement also requires the opening brace. So the switch statement, the way it works, it just tells you, give me some kind of expression or variable which I can map into a set of these case labels. So look, my case values are predefined as an enumeration, which is a set of constants. So it should be pretty recognizable. This is a constant, this is a constant, and the default case is like everything else. Let's run this example and see how it behaves. So we just replaced this if-else with the switch with cases. Again, how it works. I'll show you in a second. So basically what we do is that we switch evaluates this thing once, and if it's a mushroom thing, it's gonna jump from here directly to this case, and it will begin to execute whatever's inside this case. So let's see how this works.